still working on EE9 today, where we have talked about independent and dependent variables. We're still going to be looking at that, but now we're actually going to take a coordinate plane and make a graph from the coordinate plane and figure out its function rule. So let's take a look at this one right here. We have to, first thing we have to do is plot. Well, we have them plotted. We have to actually write the ordered pairs for the plots. So let's get this first one. We have 0 for an x value because we're not going right or left to any. And then we're going to go up 4. So that gives me 0, 4. Now, we can make this a function table where we have 0, 4, which is our order of operations also. Now we're going to look at another one where we're going to go right 4, up 8. So right 4, up 8. Now we've got to figure out what our rule is that will go along with this function table and this graph, because these two are the exact same things, just different ways to interpret your information, okay? So we need to now figure out our equation that goes with this. Now notice I said equation, so we need an equal sign, and we also need a variable by itself. Now remember, your independent variable is going to be your x, and your dependent is your y. So your y is going to stand alone, okay? It sounds a little backwards, but your y cannot change unless your x changes. So whatever happens to the x is going to affect the y. So basically what we can do is write this as y equals something plus x times x whatever. So y equals whatever you're going to do to x. So we need to figure out what can I do to x to get to the y. Okay? So 0 is not that easy of a number to start with, because you can say 0 times whatever. You can do anything you want to there, okay? So let's try starting at 4. 4 times 2 gives me 8, okay? Okay, let's go back and look at that. So if I say 4 times 2, go back and try 0. If you say 0 times 2, you're going to get 0, not 4. So the only thing I can think now is I've got to add, because if I add, that means I can add to 0 to get to my y. If you multiply anything to that 0, you're going to get 0. So therefore, I know I'm looking at an addition problem here. So let's try plus 4. 0 plus 4 is 4, and 4 plus 4 is 8. So that means my rule is going to be x plus 4. So whatever x is, we're going to add 4 to it to get the y value. Okay, so here's our graph. We took our graph. We plotted our ordered pairs over here. Then we came up with a rule that would make this situation true. All right, so let's look at our other one. All right, so on this one, we're going to look at it just a tad bit different. We're going to first plot our points. So the first one we have is 0, 0. Now again, we can take this ordered pair and make it into a function table. That's completely fine. So first one we have is 0, 0. The next one that we have is 2, 6. 2, 6. And then the next one, we're going to plot one more. It's going to be 4, 12. Now, again, 0 is not the easiest one to start with, because if you multiply anything to 0, you get 0. So basically, I could pick something and say 0 times 1, I'm going to get 0. I could say 0 times 10, I'm going to get 0. So let's start with the 2. What can I do to 2 to get 6? So I could add 4. I could easily say 2 plus 4 is 6, but then check it with this one. 4 plus 4 is not 12. So plus 4 would not work on this problem. So now let's go back and let's look at another thing. Let's try 2 times 3. So 2 times 3 is 6, and 4 times 3 is 12, and go back to 0. 0 times 3 is 0. So therefore, my function rule is y equals x times 3, but you could also write that as y equals 3x. Okay, so just remember, you can do exactly the opposite of what we did yesterday. Yesterday we had the function table and then we plotted. Today what we have is the coordinate plane. We make a function table and then come up with our function rule.